how the a value affects the parabola. So the a value is the thing in front of x squared. So if we make it negative, this black dotted graph is the original x squared. If we make it negative, it flips it upside down. Does that make sense to everyone?
Yeah.
Yeah.
Yep. Hudson, Colin, make sense to you?
Yep.
Okay. All right, so then on the other side, if we multiply it by a number, it stretches it vertically. Now, by stretching vertically, that means up and down. So think of a rubber band. If you were to pull a rubber band and pull it and stretch it vertically, it gets smaller, like this way. Do you see how the red is narrower?
Yeah.
The two sides get closer to each other. So when you are pulling something taut, when you are pulling it tighter, the two sides will get closer together. So the bigger the number is in front of x squared, the skinnier the parabola will get. And then if you were to multiply it by a fraction, though, a number smaller than 1, then it makes it flatter and fatter. Okay? So we're going to do this to the extreme now. I'm going to pull up Desmos, and y'all can use this if you want to while you're going through the delta math to make sure that you understand it. So if I have y equals x squared, I'm going to make this one the black dotted line so we know what it looks like. So this is what the original graph looks like. Give me a really, really, really big number, Hudson.
38.
Okay, so if I have 38x squared, look at how skinny the blue parabola got. Josh, can you give me an even bigger number?
1 million.
Wow, okay, so we're gonna go 1, 1, 2, 3, 1, 2, 3. Now do you see the blue line? It's like practically touching itself in the center. The parabola is so skinny that it looks like a straight line. But let's say it was 1,000 or 100. So it's getting skinnier and skinnier the bigger I make the number. Okay, give me a fraction, Colin.
1/2.
Okay, so if I do 1/2, does everybody see how the blue is now wider?
Yes.
Yeah.
Okay, Katie Rose, can you give me another fraction?
3/4.
Okay, let's try 3/4. Oops. And this one's only just a little bit fatter, but it's definitely fatter. Let's see, Najee, can you give me a really, really small fraction?
1/28.
Okay, 1/28. Look at how wide that one got,
Wow.
right? What if I did 1/100? Or 1,000? Look, it's almost a straight line again.
Ooh, add one more 0.
Oh, crazy. Okay, now what would happen to this blue graph if I were to make the 1/10 negative?
It would get smaller.
It would get gigantic.
Let's see what happens. It flipped over. So anytime you have a negative, it's going to flip it over the x-axis like it's a mirror. So let's say we started with just 3x squared. When we make it negative, it flips it over. Look, I can make it dance. Okay, but does that make sense to everyone?
Yes.
The 3 different things, what
Yep.
they do. A negative flips it over. A
Fraction makes it bigger.
fraction makes it bigger, and then a whole
Bigger
number
number makes it smaller or thinner. Or
Yeah.
skinnier.
Okay, so for the delta math, what I added, so yesterday we added the zeros and other features, and then today I added the parabola A value. So what you're doing is matching the functions, the a value, to the graph. So which one of these 3 graphs is facing up like a U?
First one.
One.
The first one.
Last one.
And so that means that our a value is positive. The only one with a positive value is this one. Oh, it's under it. Sorry. It's already there. And then which one looks skinnier to you? The second one or the third
All right,
one?
second one.
So if it's skinnier, do I want the number to be bigger or smaller?
Bigger.
Okay, so that means I need to flip.
-4. Yay, we did it.
And let's check it. Yay, we did it right. Okay, so let's try one more together.
That's right.
It's all correct.
It's
Oh.
all already correct. Good.
Yeah.
All right, let's try one more. Maybe we'll get something different. Okay.
Okay, flip the positive one with the 0.25.
Yeah,
So this way?
Yeah,
Okay. And then what else?
that's correct.
That's it?
yeah.
Wait.
Okay. All right. Okay, so if you're getting confused though, and you're a little bit stuck, then what you could do is use Desmos. So let's see, this first one is a equals 4. I could plug in 4x squared here. And this one's pretty skinny and it's facing up. Now it's not in the exact same place, but these 2 graphs, the shape of the U looks very similar. So I know that that one's right. These happen to all be right. But let's say I type in negative 0.25. I know that the graph should be upside down and it's pretty fat. So that would be that one. Make sense?
Yes.
Okay, so if y'all are all feeling good about this, then you just have time to work on your Delta Math. On Monday, we will do a review. I'll hopefully post it sometime over the weekend, but on Monday we'll review because on Wednesday, you're gonna have part of your test, and on Friday, you're gonna have part of your test. And all it will be over is this right here, the A values. And it'll also be over the parabola features. Okay?
Okay.
Right.
All righty. Then if y'all are good, y'all are all good to sign off. Najee, if you want to hang back, that's fine.
Bye.
Bye.
I want to start with Najee because I'm also confused on what he's also asking.
Okay. Okay, so for this one, it's asking for the vertex. So what I'm going to do is I'm going to copy this function and put it into Desmos. So negative x squared plus 8x minus 19. Okay, and the question is asking for the vertex, and I know my vertex is the point at the bottom or the top of the parabola. And when I roll my mouse over it, it tells me that the point is 4, negative 3. So I would have 4, comma, negative 3. Does that make sense?
Yes, but I have a question.
Uh-huh.
How can we figure it out? Because I'm sure on the test you won't let us use that website.
No, for this I will. I would expect you to be able to do it in a graphing calculator, and I know that most of you don't have graphing calculators. If you wanted to learn, Najee, how to do it without, let me find a different example there.
I have a graphing calculator, but I don't know how to plug it in.
You would press on the top left of your graphing calculator, there's a button that says y equals,
Yes.
and you would just type in the equation.
Can I go grab one and do one as an example with you?
Sure. But algebraically, Hudson, if you wanted to find the axis of symmetry, you can either use Desmos. So here was this one, and the x coordinate of your vertex. What's the x coordinate?
4.
Yeah, so then our equation would be x equals 4. So
Okay.
for this one, though, if we were to do it algebraically, what the equation that you use is x equals negative b divided by 2a. So our b in this case is 0 divided by 4. 0 divided by 4 is just 0. So our equation would be x equals 0.
Wait, so I don't get that BA thing.
Oh, sorry, it's not 0, it's 12. So the equation is just negative b divided by 2a, and your b is the number in front of just the x, and your a is the number in front of the x squared. So in this case, if I were to plug it in, I would have negative 12 divided by 2 times 2. This is harder to do here than on the whiteboard.
Can you show me how to do it on the?
Yes, just 1 second, Najee. So this is the formula. Najee, you might want to see this too. This is the formula for finding the axis of symmetry, negative b divided by 2a. So this is my b is negative 12 and my a is 2. So I just plug those in. So negative 12 divided by 4 is negative 3. So I would have negative times negative 3, which is just 3. So this would be my answer for this question. If they ask you to find the vertex algebraically, meaning by hand, Najee, you would do what I just did to find the x coordinate, and then you would plug it back in to find the y.
Will
So
this
my
be on the test?
What?
Will this be on the test?
No.
Okay.
So you would plug this x value 3 back in. So you would get 3 times 3 is 9 times 2 is 18 minus 3 times 12 is 36. So 18 minus 36 would be negative 18. And so the vertex would be 3 comma negative 18. But in your calculator, you can find this just fine. The only part that would be on the test by hand is this formula, and I'll give you the formula.
Oh, okay.
So you just have to plug in the numbers. But so on your calculator, let me find a picture of it. Do you have a TI-84?
TI-84 plus CE.
Okay.
Yeah, that's the one I have.
Oh my gosh, come on. I just want the picture to be bigger. So what you're going to press is the Y equals button right here.
Yes.
You'll press that button, and it should take you to a screen that says Y1.
Yes. 1, 1, 2, 3, 4. Like.
Okay, so in Y1, you'll start by typing the equation. So let's say you wanted to type this equation here. So you would start by typing the negative, and then you would use next to the green alpha button, there's one that says xt theta in to the right of the green alpha button. Do you see it?
Yes, I did that.
So you'll use that X button.
Okay.
And then you'll use underneath the green alpha, if you follow it down 1, 2, 3 under that, there's one that has the little 2 for squared.
Yes.
So that would be x squared. And then the equation was minus 8x. So you would just do minus 8 and then use that X button next to the alpha again.
Yes.
Minus 23. So I would type in minus 23. And then on the top right button, there's one that says graph.
Wait one. Let me try it one more time. Sorry about that.
That's okay. Make sure at the beginning you used a negative, and that for all the other ones you used a minus.
It's not giving me a graph. It's giving me like a bunch of dots.
Okay, so go back to your y equals button.
Yes.
Gosh. And in the top left, do you see where it says plot 1?
Yes.
Is that plot 1 dark?
Yes.
Okay, so use your up arrow button
Oh, I got it.
and then click enter to unhighlight plot 1.
Oh, now it's working.
Okay, and do you see a picture when you click graph?
Yes.
Okay, and can you see the top of the vertex?
No.
Okay, so let me,
Wait, there's no image. I thought it was drawn, but it stopped. So let me try
Okay.
one.
so
Negative X
let me, hang on one second. Negative x squared
minus
minus
8.
8x minus 23. It should show in the bottom right-hand corner. So what you're gonna do now, let me see if this works for you. Click, do you see the middle button, zoom? In the top row, the middle button says zoom.
Yes.
Okay, so press that one. And then press the number 6, and that'll take you to zoom standard. So if you click zoom 6,
Oh, yeah, now it worked.
yay.
And now you can just move around
Hmm.
on the axis of symmetry.
Yeah, and I can actually, so Najee,
Yes.
if you click the blue second button,
Yes.
and then click the trace button up above it in blue, what we're actually using is called calc.
Just trace button in blue.
So what you hit the blue button second, and then you
Yeah.
hit trace.
Where's Can you show me your traces? Wait.
It's the 4th button on the very top row.
Yes.
The word in blue above it is calc. So by pressing the second button, the blue button, now we're using the blue word. And so that would be second calc.
It says value 0, minimum, maximum.
Okay, so what was on your graph? Was it a maximum or a minimum?
What's this on my graph?
Yeah, so this right here, do you see my screen?
Yes.
Is that a maximum or a minimum?
Maximum.
Yeah, so you're gonna scroll down to maximum.
Y equals to negative 23.
Uh,
Sorry.
and it says y equals negative 23, and what does it say the x equals?
0.
So does it say the word left bound
Where?
on your screen?
Yes.
Okay, so what that means is it wants you to move the cursor to the left of the vertex. So press your left arrow button a whole bunch of times.
Oh, here.
And then once you've moved it, press enter. And then your screen should say right bound. So you'll move it to the right side of the dot.
Oh, yeah.
And then hit enter.
Negative,
And then it should say guess, right?
yes.
So guess, try to move your cursor so that it's right on top of the vertex.
Okay, -4.
and then hit enter.
Yes, it shows -4.
And it says -4, comma, -7.
Yes.
And that's your vertex.
Oh, thank you.
So either one of those two ways will work.
That's probably easier.
Yeah, this way that I just showed you is the way to get it the most precise.
Yeah.
But for your class, you should be able to just move it to find it.
Okay. Thank you very much.
You're welcome. Good luck.
How much do I have to do today, by the way?
All of the Delta math.
All of it?
No. All of the Delta math is due next Friday.
Oh, okay.
Your test is Wednesday and Friday. So in order to get the most amount of practice, I would recommend having it done by Wednesday.
To have it done by Wednesday. And
But that's not a requirement. I'm just recommending it. But it is due on Friday.
Are we required to do it today?
What?
Are we required to do it today?
No.
Oh, okay. Thank you.
All right.
Have
Have
a-
a nice weekend, Najee.
Have a nice weekend. Bye-bye.